So, Dr. Arnab Ghosh. So let me give a brief description about himself. So Dr. Arnab Ghosh currently is working as an assistant professor in the Department of Electrical Engineering at National Institute of Technology, Rourkela, and is associated with Center of Excellence (COE) on renewable energy systems. He has been actively involved in research on different control and power electronic converter design for renewable power generations. He is an IEEE senior member and chartered engineer. Currently, he is associated with four esteemed projects such as one bilateral international research project of Indo-United Kingdom joint project, collaborated with North Umbria University, Newcastle, United Kingdom, Indo-Sri Lankan Joint Research Project collaborated with University of Muratua, Sri Lanka, Impacting Research Innovation and Technology 2009 imprint 2 phase 2C, and Science and Equity Empowerment and Development seat DST. He was received he has received Young Scientist and Technologist Award from DST Government of India. Recently, he has received IEI Young Engineer Award 2022-2023 in the Electrical Engineering discipline. He is author of more than 80 research publications in internationally reputed journals and conferences. His work has been accepted by IEEE transaction on power electronics, IEEE transaction on industrial application, IEEE transaction on power system, IEEE transaction on industrial electronics, IEEE transaction on computer consumer electronics, ISA transaction, Journal of Energy Storage, and many more. His research interests include the power management in hybrid microgrid, design of charging station for EVs, control of microgrid, switch mode power converter, nonlinear dynamics of switching converters, etc. Dr. Ghosh is supervising undergrad, postgrad, and PhD student in the domain of design of power electronics converters for renewable applications and controls for smart grid and hybrid microgrid. So we heartily welcome Professor Arnab Gayan. We are happy to have you in this session. So please enlighten us with your speech. Thank you.
Thank you for giving the brief about my profile. Thank you, all of you. We're just starting the sessions just now. Just for a moment. Okay, so very good morning, all the esteemed participants. Okay, I am Arnab. I'm Arnab Ghosh, going to deliver my presentations on intelligent power management schemes for microgrid applications. Okay, so as you all are aware about it now, because we are talking so much on the sustainability. Okay, the motivations of that short-term course as well as faculty development programs is based on the sustainability in different aspects. Okay, it's a multidisciplinary course. That's why we can able to explore different domains as well as how it is applicable in our current current life. Okay, current life, that is more important. and how we are going to implement them in the technological aspects as well as implementation aspects. Okay, so we know like that there are different kind of aspects are there. Suppose technological development, then implementations, all those idea in the practical manner. Okay, so that's why now this idea, the concept of the microgrid is very much appreciable and implemented for different areas. Okay, especially we are from we are from Sundargarh districts in Odisha. So basically, in these districts, in this district is quite backward area. Okay, quite backward area means it's quite hilly area. A lot of tribal villages are there. So government having a lot of trust on that how their lifestyle can be improvised in the technical aspects. Okay, so technological aspects means the electricity is main heart, or you can say like that soul of any kind of civilizations as well as the technical implementations. Without having electricity we cannot do anything. Okay, so whatever technology we have, so implement them. So first we need to know how we can utilize it, how we can generate it, and how we are going to implement the idea. Okay, suppose we are in our very conventional scenario. Okay, in when that first the power plants are installed in the British government, that time it was normally designed based on the base loads idea. So what is the meaning of the base load? Base load means suppose you are having the locality, so locality, and we are going to design the power plant nearer to the locality. After that, a lot of technology has came. Then we are talking about the grid concepts. Okay, so we are aware about it that sometimes the power is coming from that central grids. Okay, one organization is there, Power Grid Corporation India Limited. So they are normally balancing the power from different area of the country and transferring the power from one zone to another zone. Any kind of crisis is happen. Suppose any festival season is there, then the power is coming from a different area of that a different part of the country to other part of the country. Okay, like that. Okay, so that concept is it's really good and appreciable, but still now the government having the idea how we can able to that the term that Atmanirbhar Bharat. So main idea is that how we are making the entire system is standalone. Standalone means self dependency. Okay, so why we are sorry. So how we can able to generate the power and how we are able to utilize the power. Okay, so that kind of concept is coming in the sense of that captive generations means that you are having the local in your locality you are installing some renewable sources and you are extracting the power from there. So solar having very good potential in any aspects, and we are having some other source of energy, some other source of alternate energy or alternative energy like wind in our area, that biomass gasifier, that Odisha having very good potential of picohydrals. Okay, picohydral. Okay, so any these 4 5 things are very common here. We can have in the good potentiality on that aspect, so we can able to utilize those power for our real-time applications. Means what we can say like that whatever sources we have, that we are utilizing from our side, as well as if we are having that surplus amount of energy, that we can able to send it or you can able to sell it to the government. That protocol has not been clearly chalked out, but self dependency or self generations of the energy is only established in the current scenario. If you are traveling from one place to another place, you can able to see that railway stations. Okay, so that that shading of the railway stations also having that rooftop solar. In your institutions or in your locality, you can able to see that lot of houses they are having the rooftop solar, especially the institutes. Okay, so if we are having the potentiality of the generations, we should use it. And now main thing is that we are having the solar panels only. Okay, but direct panel we cannot use that electricity to our normal local grids. Okay, the local grid means, or you can say like the local bus. Okay, suppose in your house. Okay, so you are getting some electrical inlets. Okay, means you are taking the connections from your local distribution center or local distribution office. Okay, so that you know that it may be, if suppose you are staying in an apartment, so you are getting the power from your apartment, but that power is coming from your local distribution office. Okay, so that is our common tendency to you, that is our common way to getting the power. But thing is that how you are managing the power, that is more important. How are you managing the power means, suppose you are having, suppose if you want to install some solar energy, okay, so you cannot directly connect with that one. Okay, so for that one we are having some interfacing equipments, or you can say like that interfacing converter in better manner to use those renewable energies for our local local bus or your local utilities. Okay, so for that we have to design some of the ideas, and our talk is based on that kind of power electronics converters, basically what type of converters we are using and how we are managing the power. Now what is the motivations for this intelligent kind of concepts? Okay, so why we are telling like that intelligent power management scheme? Okay, what is power management scheme? Basically, you know that we are having multiple sources of power. In the microgrid concepts, what we are doing, we are generating or we are installing some captive generations where the multiple sources of power is available. Suppose you are having an EV. Okay, so in this EV, what happened? So that EV you want to charge from your domestic as in your home or in your house. That also taking the power from your domestic area. Okay, so now main thing is that how the power management can be happen. Suppose in morning time the electricity requirement is less, but in evening time the demand definitely will be high. Now the winter season is going on, somehow the demand is less in the aspects of the utility. Suppose air cooler, or you can say like that air conditioners in that manner. But suppose in Rourkela is quite cold, cold area. So in this case, what you need to do, you have to install the heater. Again, it is coming in the form of the utilization of that electrical energy. Means peak demand is always be more in the evening time, and some of the times the demand also been high in the daytime if the in your system having the any office and other kind of things. So that's why the managing power, which time we have to utilize the more power and how optimally we can utilize the power, and which time we are storing the energy. That storing the energy also quite important thing. Okay, so in all the aspects we are managing the power. That's why it is called the power management schemes. Okay, now point is that why the intelligent terminology is there and how it is relevant with these applications. Okay, so now we are always talking about that artificial intelligence. We are talking about the machine learnings. Artificial intelligence means what happened the system, suppose you are using intelligent means that system having its own deciding factor. Means suppose you know that how they are relevancy with that one, that all the renewables energy, you can say like that solar energy, wind energy, this is very commonly used one and all the time it is available. But you know like that biomass gasifier and the pico or hydel, all the time it is not available. It is not the continuous process. It is only work for that when the peak demand is there. Peak demand means suppose suddenly we are using that generator, suppose we don't have that power in our home, suddenly inverter is working. Okay, in nowadays inverter is available, but you can recall after 20 years back, okay, that time inverter is not there. So we are having, now we are also using silent generator for any occasions. Okay, that time we are having the alternator, but it is not a silent one, so huge noise pollution was there. So this is only given for the mitigating the peak demand. Means suddenly huge load is there. Suppose you are taking a connections from your distribution office, so you have to write how much demand you are, how much load you want to use for it. Okay, what will be the number of ACs, what will be the normally we are taking the connections for the 5 kilowatts. Okay, so normal domestic application. Based on that they are coming and collecting the data and they are cross verifying that it is okay or not. Based on that they are giving the tariff. Now the intermittency of the renewables, suppose the solar you are not getting in the evening, daytime the solar irradiance means suppose watt per meter square, that's unit. Okay, so that also been changes time to time. Morning the irradiance is different, afternoon the irradiance is different, noon it is also different, all the time it is varying. Okay, as well as the temperature. Okay, based on the temperature the solar panel efficiency also been changes. Okay, and in case of wind, the wind speed also not been fixed all the time. You are not getting the continuous speed of the wind. No, and wind also not been applicable for all the area. Basically it is, you can able to see that nearer to the Kanyakumari, as well as if you go for the Gujarat, Rajasthan, as well as the seashore, especially nearer to the Chennai and all those things which having the big coastal area and the seashore, you are getting the high potential of the wind energy. So zone specific the renewables also been available. Okay, so the thing is that the adaptive they are in intermittent in nature, and huge highly time variance is there. I mean, based on the time their data or their results, everything has been changed. That's why that you should see your power management scheme should be equipped such type of intelligent ideology that can manage the power and maintain of your grid voltage, or you can say like that bus voltage. What is the meaning of the bus voltage? So I am taking just for a common example. So in your home, okay, so in your home, suppose like that, sometimes we are talking about the single phasing, sometimes we are means suddenly the fan speed is less. Okay, somehow the illuminations of the lamp is less, so that time we are talking about one phase has gone, means in your near a transformer one phase, the fuse of one of the phase, means there are three phases are there, RYB, another one is neutral, any one of the phase has gone. So what happened, the entire load is coming under the pressure is coming within the two phases, that's why suddenly voltage is dipping. Then what is the problem? Suddenly voltage is dipping, means we know that basic concept of the transformer, means in normally the convention of the energy, conservation of the energy, we are talking about energy is constant. It cannot be generated, cannot be even destroyed, means only transformations is possible from one energy to another energy. And you know that power and energy, the relation between the power and energy is that power is then energy is an integrating factor, means suppose you are multiplying time with the power unit is kilowatt, okay, and the energy unit is kilowatt hour, means you are integrating the time with your power, so you will get the energy. More or less energy and power is nearer quantity. So if the time is constant both of the ends, so you can say like that input power equal to the output power. Suddenly your bus voltage, suppose in your home the voltage is dipping. Okay, so voltage is dipping means voltage is less. Okay, but what is the meaning of the power? Power also coming the multiplication of voltage and current. Okay, V into I. So power is constant. So voltage is suddenly dipping means current is more. Okay, if the current is more, so your appliance may be, okay, whatever electrical appliance you are using, that may be damaged. Okay, that's why all the time we have to maintain the power fixed. Okay, in any aspects. Suppose you are having the storage with you in your home, you know like that you are using the inverter. So inverter having that big lead acid battery. So suppose power is not there, online inverter is there, directly there is a change of a switch. Automatically the power switch is shifted from your line to directly inverter mode. So the power, additional power will come from your battery. So battery power output is the DC, that is converted to the AC. The purpose of the inverter is to convert the DC power to the AC power. Okay, and that is circulated to your home, and you can able to utilize that power, and you can able to control whatever thing is there. You are utilizing, end of the day you are utilizing the power. And now you can say like that, is the printer is okay for that inverter power, or can we run the AC with that inverter power? It totally depends upon your load capacity. As an electrical engineer, we can able to understand the meaning of the load, means how much current is drawing from the system. Okay, so suppose your inverter is 500 VA. Okay, and you are if you want to start that, if you want to run the AC with that inverter, is it possible? Definitely not possible. The AC load is more than that 500 VA. Okay, so if the capacity of the inverter is less than your AC, so it will draw the more current. More current, if it is drawing from the system will damage. That's why voltage profile, current profile, everything is very much important for these aspects. Now I am coming to our main discussions and main area of that one. So this brief description is needed to gather the idea to enter the discussion. That's why I am giving that generalized idea on that. Okay. So now we are talking about that why, what, how the sustainability is related to this power management scheme. So from the day one we are able to, today is our third day, so we can able to see that a lot of idea is there how we can how we are maintaining the entire systems. Okay, so like that government taking some action, national action plan NAP in 2030. By 2030 it was taken in I think 2020. Okay, so by 2030 that overall environment temperature will be reduced by 2 degrees. Okay, so for reduction of the temperature, what new thing we have to do? So we are government was taken the initiative to conserve, or you can say like that, to preserve the natural resources like forest, water. Okay, and all those things. Now different ideas they are taking. Okay, so how the carbon footprint can be reduced. Okay, so yesterday Sir was telling, means last session Sir was telling some new idea, regenerative, that agriculture, or you can say like that cultivations, all those things, means you have to in the technological aspects how we can improvise ourselves, means utilizations of more uses of more renewables energy. Okay, so transportation, sustainable transportation like EV. Okay, but there are a lot of problem with the EV current scenario also. If you go to Delhi, Bangalore, the EV is very common. Even if you go to the Bhubaneswar, so near a city, in our campus also, we are able to see some 2 3 numbers of EV. But if you want to travel from Rourkela to Bhubaneswar, it's quite 400 kilometer away. Then you are thinking about it that can I go with my own EV to Rourkela to Bhubaneswar? If you want to travel from intercity like Bangalore to any other Chennai, if you want to travel over there, so now some idea is coming to in your mind. Say, suppose if you want to need a charge, so how would you charge the EV? All those things. So sustainable transportation is highly promoted for our local activities, but still a lot of infrastructure is needed to charging stations. Okay, now that is important. So conservation of energy. Okay, now utilization of the energy. Okay, so generation is important. Now important point is that energy losses, how we can minimize the energy losses. We can take some basic example. Okay, suppose when we are in earlier age, that time we can able to see that we are having some tungsten filament lamp. Okay, like it was minimum 100 watt, 60 watt, 200 watt lamp was there. It is yellow color things was there in our home. Okay, and you can able to see different puja pandal and any kind of occasions you can able to see some halide lamp. Okay, means it wattage is quite high, nearer to that 1000 watt, means huge amount of energy losses. Okay, that time in a concept was also different. Okay, so who can able to use more energy, that person need to give less tariff. Okay, now concept is differently opposite. So those person are using the less amount of energy, so the tariff will be charged also the less. Now you can able to see the changes of that illumination load. Means suppose our lighting system, that time we are using different kind of light with having huge wattage. Now after that the fluorescent lamp has came. Okay, so like that the fluorescent lamp wattage is nearer to the 40 watt. Okay, like it is very much well known as like the tube light kind of thing. Then we are changing that to 40 watt to that. Again, right now the fluorescent lamps are there with having only 20 watt. After the fluorescent lamp, the concept was coming the CFL. Okay, so it having some ballast circuit in fluorescent lamp with having big in inductor. Okay, so that inductor also caused some energy losses. Now that ballast circuit are using for the CFL, so the fluorescent lamp shape is now very less. Now the CFL, now we are not using also the CFL. Now we are using LED lamps. In our home, we are using 9 watt LED, 2 watt LED. Okay, so 9 watt is always mostly promoted by the government. So we are getting some subsidized manner. The rate is subsidized manner. So more than 9 watt or less than 9 watt. So their rate is quite different with the LED. Okay, so that's the generation has changed with our illumination load. So now that the LED tubes also been available, means LED kind of LED strips are there, that is using just for a tube light. Okay, so in each in individual aspects, we are getting different idea, different concepts. Okay, and the different types of load in this applications. Okay, so now the generation has changed, technology has changed. Here we can able to see some air pollutions. Okay, so in our each of the states, each of the city, compared to a nearer country, so pollution is more. So that's why we have to think some more smarter, more idea how we can reduce that carbon footprint in our environment. So for that, we can use the microgrid concept. So what is microgrid? That microgrid concept is not so much new. The first microgrid installed in India, that is 1980s. We know that Ganga Sagar. Okay, so Ganga Sagar was the first microgrid in India. Okay, it was installed. It's a DG plant was there. Microgrid means that we are talking about the captive generations of your own applications. Okay, suppose you are installing some solar photovoltaic for your home, in your rooftop of the building, and you are utilizing them. You are getting the power from there. You have stored that power in your battery, and even daytime you are charging your battery, and evening time you are utilizing that energy for your own. So it's also an example of a miniature version of the microgrids. Okay, so in bigger aspects there are different classifications of the microgrid. I will coming on my some slides so we can able to discuss about the classification. So microgrid having, if you able to see the entire system, if you connect now several number of buildings over there. Okay, so several number, just for a moment. Hello. Huh? My session, my session is going on. Can I call you after some time? Sorry for that interruption. Okay, so and now the microgrid, if you install for your locality. So from yesterday we are having a lot of sessions on the IoT. Okay, IoT. Now we are talking about smart IoT, and in current scenario we are like that smart city concepts. Okay, so what happened? The microgrid means now the that difference between normal grid and the smart grid. Okay, so smart grid means that electrical transmission is definitely there. Now you are also collecting the data. Data is the most important thing in our daily life in the current scenario. So why data is important? Now, suppose you are having the solar photovoltaic wind. In this figure, you can able to see like that. There is a wind system is there. Okay, so this is solar. Okay, so battery is there for the storage. Okay, EV is there. Okay, and the building also be there. So a lot of things are there. So all the time, what happened? If you want to control among of them, so what is the important thing? You have to fetch the analog data from the system. Analog data means what is your generation right now. Okay, and what is your load demand right now. Okay, if the generation is more than of your load demand, then no problem. Okay, so load can be run by the whatever power generation is there, and surplus power should come to the battery. Battery should be charged. That storage is there. This is your storage. Okay, and here, okay, so that's why the monitoring and the data is important. How you are getting the data? That analog data is converting to the digital data, A to D converter, and that data will be processed in the supervisory system. The supervisory system is installed inside of your computer. It can be the microprocessor we are not using right now, the microcontroller, or you can use like that FPGA or the DSP processor, that everything incorporated with your computers. Okay, now the data will be analyzed through the controller, and finally that control output will come, and that also been converted from the digital to analog platform, and that pulses will coming to the driving the converter, power electronics converter, that is connected to your solar photovoltaic or the wind, and you can able to control both both the converter and the renewables will get the data. So all those things what happen? So you are collecting the data and the processing of the data, and finally you are monitoring. Monitoring means what? What is your demand? What is your generations? How much energy storing? Suppose your demand is more than of your generation, then what happen? The additional energy will come from your storage. Suppose still the storage is not sufficient to mitigate to drive all the loads, then what happen? From where additional power will come? Then additional power will come from your normal bus or normal grid. So that is your conventional grid. There is a circuit breaker that is connected with your system. That additional power will come from your conventional grid to your microgrid. So entire system is connected, and there is some that applications, like that IoT is basically were applicable for this one. Different kind of things, data and working with the data and controlling the converter. That is the main important thing. So what are the most important parameters? Energy demand, monitoring the system, control the system, and maintain the balance, the stability. Okay, so the system should not be the score, should not be collapse. Okay, if that energy is not there, so there is a high chances to collapse the system. So system should not be collapsed. So there are different yeah, so residential, commercial load, generations. Okay, the renewables are there, storage are there. Storage you can able to see the bidirectional power flow. So both of the end it can be possible. Again there is a again there is with the utility grid, conventional grid, there is a bidirectional power flow. So both of the side, the utility grid can take the power from your domestic microgrid, or you can take the power from your utility grid. So both of the way it can be possible, but first priority is your storage. Okay, so if you get the power from the storage, you need not to depends on your conventional grid. Okay, these are the very typical structure of the microgrid. So the basic definitions are given from that one that we are already told you. Electrical grid. Okay, now microgrid is the localized group of electricity sources. Okay, and the load that normally operate connected to the synchronous with the traditional wide area synchronized grid of the microgrid, but can also disconnect with the islanded mode and the functionally the autonomous of the physical or the economical conditions of this grid. Okay, so it can be operated in islanded mode or the grid connected mode. And what is smart grid? Smart grid is that microgrid, or you can say like that both side you can able to both of the end you can able to transfer the power. So that will be coming in the smart grid head. Okay, so tile and power transfer. So now what are the classifications of the microgrid? Here based on their application, suppose microgrid is there, so mode of operations, it can operate in isolated condition or islanded condition or the grid connected condition. Islanded condition means you are not depends on the your external grids. Okay, whatever generation is there, that is sufficient enough for your mitigating the demands, power demands. So that is islanded mode. Suppose islanded mode is not not optimum utilize sorry, not mitigating the power, so you have to connect your microgrid to the conventional grid, that is grid connected. Now based on the type of the microgrid also be there, that can be the AC grid, it can be the DC grid, or hybrid means both AC DC will be present there. Source. Okay, what are the source are there? So it can be the renewable sources, diesel sources, hybrid. So hybrid means renewables and diesel both are present there. Now what are the examples for the renewables? All are aware of it: solar, wind, pico, small hydro, pico hydro, biomass, as well as hybrid means all are present there. Okay, then scenario based, where you are implementations, where you are doing the implementations of the microgrid. It can be the residential applications, many are domestic, then industrial applications, okay, for the industry purpose, and the commercial application means the tariff generations and all those things. Okay, so money related things are there in the commercials. Okay, you are selling or you are buying. Okay, so all those things are there. And the based on the size means load size. Okay, how much maximum it can be done? So it is that greater than 10 kilowatt, sorry, less than 10 kilowatt. Okay, so another one is 10 kilowatt to 1 megawatt, and last one is more than the 1 megawatt. These are the very basic classifications of the microgrid. Okay, now here we are able to talk the different kind of different types of microgrid. First, we are talking about the DC microgrid. Okay, so what happened with the DC microgrid? So whatever sources you have, okay, that sources is converted to the DC. Suppose you are having solar photovoltaic automatic output is coming DC. But if you are having the wind energy output is AC. But if you are having the bus that is DC bus, then what happens? So whatever sources is there, you have to convert the DC to DC. So you cannot connect the DC with directly to the AC. So the basic conversion is required. So who will do the conversions? The power electronics converter. In our early days, we are talking about the diode rectifier is there, that is converting the DC to converting to the AC to DC. So in this case also wind we are able to convert the AC to DC, but diode is uncontrolled rectifier. Okay, so if you giving input you will get the output, but we are required some of the control switching device. So whatever input is given, so based on our requirement we can able to control the device, will get the output. Okay, so DC microgrid means you can able to see that line is your DC line. Okay, now different this is the sources are connected to the DC line. Here you can see the load ends, all the load are connected. So AC load is direct, not able to connect directly DC power. Okay, that's why one converter is required, that is converting DC to AC converter. Here DC load is there. Again, another mismatch can be possible. Suppose your bus voltage is 48 volt. If you want to run a DC load, that your battery charger. Okay, so battery charger is there. It is only for the 12 volt. You cannot connect directly 48 volt to 12 volt. So your battery charger will be damaged. When your load will be damaged. That's why one adapter is required. Means you are converting that DC power to the DC, but it will be stepping down that value. Okay, or stepping up the value. So these all are the output loads, and it is your input supply from where directly connected to the system. And finally, you can able to see this is your storage part. Okay, so in the storage part, so there are different components. Suppose what are the important component? First one is the battery storage. Battery having that high energy density means suppose we are taking a lot of examples. So battery directly when the power supply is not there, means suppose the renewables are not there, that time who will provide you the who will provide you that energy? So battery will give you the energy. And why, what is the capacitor? It is super capacitor module. Okay, so what is the purpose of the super capacitor? Basically battery having that good energy density, or you can say but supercapacitor having good power density. So what is the meaning of both of the differences? Energy density means you know that in our basic we are talking about the rise time. Okay, rise time or the response time means if you are giving any of the response, any of the set value, okay, how fast you are reaching that value. Okay, means suppose we are running for a sprinting. There is a sprinting competition, so 100-meter race. So who will get fast? Who reach the end point quickly? That person will first. Okay, means same thing also happened. So in the response, in electrical response, who will first reach the set value? Okay, that time constant is better. Okay, and that is also known as first response. The rise time also been fast. Okay, and the same thing whose response is sluggish means that is not able to reach with quickly to that end point. So its response is not good. Battery also having the same problem. So it can reach the steady state value, but not immediately. It is taking some time to reach that value. So that's why in that problem, in that durations, so what happened? The transient will coming, the uncertainty is there because of that high load demand. So who will take care about those problem? So the supercapacitor is there that can taking care about that transient problem. Okay, so it can work in only for the transient domain. Steady state it is not work. Okay, so directly it is reached the steady state value. After some time, the battery will take care about the take the charge from the supercapacitor. So both are working. So it is known as the hybrid storage module. Okay. Now why EV is connecting also be there? Okay. Suppose you know like the different type of charging process is there in EV. Okay. Type 1 charging, type 2 charging, type 3 charging or fast charging. Okay, so normally, like that if you are having two-wheeler, if you two-wheeler, so you are giving directly connecting to the plug point, there is the adapter, you are charging them. So how much time is required? 5 hours, sometimes it is taking 6 hours. Okay, it is taking some good time, normal. Okay, so for that, what happen if you connect your EV? Okay, so if you connect your EV and evening time, you are having more energy demand. Okay, so you are managing your power management scheme such a way so evening time the additional power is coming from your EV also. Okay, then night time, midnight time that you are not using the power so much way. Now we are talking about intelligent AC. Okay, means what? AC also automatically turned off. Okay, so it is sensing some of the parameter. Okay, suppose it can sense some of your VMR value or whatever things are there, technologies are there. Now all the systems are very smart. Means we are processing the data. Okay, from the computer science end, you are processing the data. Now the thing is that when the product is there, product is involved in the system, that data should be applicable in the real time. Okay, so yesterday we have seen a lot of real-time applications. Okay, how all those things are there and now how they are implementing to the real time. So processing of the data is very important and the time complexity as well as the time processing time should be the less. Okay, so based on that you can able to see evening time suppose another more demand is required. So additional power will come from your EV to your domestic load. Okay, so that's why the power management also been important. Okay, now what is the AC microgrid? DC microgrid and AC microgrid more or less same. In AC microgrid, what is that thing? Instead of DC bus, we are using AC bus. Here, AC microgrid, we are using AC bus, but DC microgrid, we are using DC bus. So whatever sources are there, we are converting through the converter to the AC and connecting to the AC bus. Okay, and the storage is there. It is bidirectional converter is there, that is called DC-AC bidirectional converter, and we can able to store it. And DC bus also be the same thing. The photovoltaic is there. We are converting the DC to DC and feed to the DC bus. So here we can able to see the wind turbine. This is your AC. So it is converting from AC to DC conversion and connected to the DC bus. So there is a difference between AC microgrid and the DC microgrid. So both we can able to see over there. So what is the problem in that DC microgrid? In the previous here only, so whatever sources you have, the output of the source is different. Suppose wind, the output of the wind generator is that AC. Output of that picohydral, that is output of the hydral, it is also the AC. Picohydral AC. Okay, output of the biomass gasifier, it itself has an AC. So whatever AC is there, so you have to unnecessarily convert the AC to DC to feeding to the DC microgrid. In case of AC microgrid, what happened? The output of that solar photovoltaic is DC, but unnecessary you have to convert that DC to AC. Then you can feed to that AC to your AC bus. The bidirectional converter means suppose the storage. You know that battery normally charging in the DC only. That is well known to all of us. So whatever things are there, whatever converters are there, so the charging and discharging basic thing is the DC. So if you using AC bus, AC local bus, so that AC should be converting to the DC and you can able to charge the battery. That is another problematic job. Okay, so that's why you can the next concept is coming, that is hybrid microgrid. So in what happened in the hybrid microgrid, here you can able to see the hybrid microgrid. So from that one, whatever DC from your DC idea, so whatever converters are there, DC loads are there, or DC sources are there, they are connecting to the DC bus. This is your DC bus, and whatever AC sources are there, suppose diesel generator, wind power, okay, grid, when a conventional grid, this is your transformer, circuit breaker, AC load, so that will be connected to your AC bus. So here you are using that solar photovoltaic, that is a DC-DC, and the battery. Okay, wind also you can use, but you will need to convert it. So all the DC sources are connected to the DC bus, all the AC sources are connected to the AC bus. In between one converter is there, that is called interlinking converter, that is AC-DC bidirectional converter. So this is your main converter, this is backup converter. Main converter means Normally this converter is working, and backup converter means when you are taking the shutdown of your entire system, then the backup converter or the maintenance of your main converter, or anyhow the main converter is damaged, then the backup converter will working on that. Your main fundamental idea is to make the stability, voltage stability of your AC bus as well as the DC bus. So for that, you want to control the converter, that this AC-DC interlinking converter, or you can say like that only you are working on the DC bus, then you are controlling the DC-DC converter to maintain the DC bus voltage stable. Mane whatever load, like that suddenly more load is coming, means it is taking, it is drawing more current, but the grid voltage or the bus voltage, DC bus voltage should be fixed. Initial dipping is there, like that electrical time constant is better than of your mechanical time, means it is quite less, the value is less than your mechanical time constant. So whatever disturbance are coming in the electrical circuit, it should be, so any problem with disturbance are coming, so you can able to see their presence very quickly. So you have to mitigate the issue or mitigate the problem very soon. Whatever controller you have to design, whatever things are designed, so that should be respond very soon, otherwise there will be disaster. So function of the power electronics interfacing model. Now like the different renewables are there. So that renewables are connecting to your bus. So that's why what you need to do. You have to connect, okay, different sources. Okay, so you have to connect the different renewable sources through the converter. So that is the basic function of that converter. It is called the interfacing converter. That is, interfacing converter means all the renewable interfacing with this converter to your DC bus or the AC bus. Second type of converter is what? This is bidirectional converter, DC-DC bidirectional converter. The DC-DC bidirectional converter is normally connecting with your storage system and the DC bus system. Okay, that is DC-DC bidirectional. To maintain the DC bus voltage, the DC-DC bidirectional converter having huge impact on the system. Another converter is there, that is called AC-DC bidirectional converter. Suppose like that both of the microgrids are there, both of the bus are there, so AC bus like previous slide and the DC bus. So AC bus having the surplus power, so additional power will come to the DC bus, and through DC bus it is charging the battery storage. So the AC-DC converter, bidirectional converter having a prominent role to transferring the bidirectional power from DC bus to AC bus or AC bus to DC bus. So power management algorithm is there, that is controlling the gate pulses of both the bidirectional converter like AC-DC bidirectional converter or AC-DC bidirectional inverter or the interlink converter. Both are all are same, and the DC-DC bidirectional converter to maintaining the bus voltage. Okay, that's the basic concept. So we are having some protocol, the standard. Okay, suppose like that those are working in that IoT, all those things, the communication, there are a lot of communication protocols. Okay, similarly in our power electronics converter we are also maintaining some of the protocols, means power quality issues. Practical scenario, whatever converter, whatever loads we are using, all are the nonlinear load, means like that CF, we are talking about that LED lamp. What is LED meaning? Light emitting diode. Diode is an example of a linear circuit. No, it's an example of a non-linear circuit. From our basic first year we are talking about okay, so linearity means what are the linear equipments, whatever theorems are there, laws are there, they are normally Ohm's law. We are talking about the Ohm's law, na? Starting with that on the Ohm's law in class 8. Okay, so you are talking some prerequisite. Okay, so we are talking like the temperature constant. Okay, so whatever physical thing that is constant, pressure constant, means anything changes, their property should be constant. Okay, so if their properties has changed, so it is not following the Ohm's law. Ohm's law still it is an example of a linearity zone. Okay, so with the linearity it can work. Okay, similarly, whatever converter, whatever applications we are using, suppose all are the examples of the non-linear. Suppose light LED is an example, non-linear. Diode is there. Diode characteristics is not a linear one. Okay, so so if you able to introduce the nonlinear thing in your system, so the power quality issues will be there, unnecessary oscillations, everything will be there. So it is distorted. We know like that our basic Yeah, nature of the power, AC power is the sinusoidal. If you use some non-linear load, you are using the linear load, then voltage and current pattern are same. We are talking about no, so resistive load, voltage, current, all are in phase. Okay, so they are in linear. Suppose if you are using the non-linear load, so current pattern will be distorted. Voltage pattern, whatever things are there, but current pattern will be totally distorted. Then the THD harmonics that will be coming. Okay, so if it has coming to the system, then what new thing we can able to see, the THD value will be more. If THD value is more, so the power quality issues are coming. So that's why you have to maintain some of the protocol. In our case, we are using IEEE protocol. So that percentage of that is should not be more than 5%. It should be the less than 5%. Now, the how we are going to design that power electronics converters. Okay, so that designing we are having some flowchart kind of thing. So first we have to select the topology of the converter. Okay, so topology means suppose if you want to step up the voltage, so you have to select the step up converter. Means we can take some example where it is required. Suppose you are having a bidirectional converter. Means your grid voltage is bus DC bus voltage. We are talking about DC bus voltage. DC bus voltage is 48 volt, and you are having a battery having 12 volt. Now you want to discharge the battery. Okay, so your battery is connecting to the DC bus. Okay, now you want to discharge the battery. Then what happened? So battery is discharging from 12 volt to 48 volt. Practically it is possible if you directly connecting to the battery and in a 48 volt. No, it is not possible. So what you need to do, you have to connect the battery through a power electronics converter to the DC bus. Okay, that power electronics converter, it is known as the chopper. Okay, DC-DC converter. That DC-DC chopper converter is converting means 12 volt to that is stepping up. Battery is trying to discharge. That's why 12 volt is stepping up to the 48 volt. Okay, then it can be discharged. Okay, so the topology, what kind of topology is required? That is known as boost converter. Okay, means the bidirectional converter is working in the boost mode. That's reverse thing happened. Now battery is totally discharged. Now we want to charge the battery from that 48 volt DC bus voltage to the 12 volt DC battery voltage. Okay, then what happened? So 48 volt is using to charging the 12 volt battery. So what is the voltage? So both the cases that DC bias voltage is far quite high than of your battery voltage. So 48 voltage should be stepping down to the 12 volt. Otherwise, it cannot be charged. So what happens? So what type of converter you are using? You are using step down converter. Okay, so you are using that buck converter. So bidirectional converter you are using, that is a that can work in both the modes, boost mode as well as the buck mode. So the topology selection is very much important, which topology you are using. Then the mathematical modeling. So now we are talking about whatever things are doing. So you are writing a code in the computer. So in which domain you are writing? You are writing a code, means you are calling a function, whatever things logic is there. So logic means it's a mathematical logic. It's not like that arbitrary other things are there. Emotional logic is cannot possible. Okay, yeah, emotional logic is possible, but its represent should be mathematical manner. Okay, so whatever things are there, your topology, it should be represented in the mathematical form. Otherwise, what happened? You cannot define the system. So how your mathematics is accurate to modeling the system. So modeling is very much important of the topology. So that is the mathematical aspects is important. Now, why the mathematical modeling is important? To control the devices or to control the converter. So controller means again it is a mathematical logic. We can take some example. Okay, suppose in our lockdown period we all are aware about the cooking and everything. So then what happens? Suppose in our hand, okay, we have just touched a hot bowl. Then what happened? So suddenly hot bowl we are touching. So we are just suddenly skip our hand or we are just remove our hand. Basically what happened? when in your hand having lot of temperature sensors. Okay, so that is touching to the bowel, then that temperature sensor are sensing the values. Okay, sensing the signal. Okay, sensing the value, whatever data is there, it is collecting. Then we are having the nervous system, so sensory nerves are there that carrying the electrical signals. Okay, and communicating to the brain. So brain is our processing unit. Okay, so brain is our processing unit. There is some threshold value. Okay, how much value is our tolerable range? Okay, so in our first year we are doing the register 10 gold band, silver band. One is 10% tolerance, one is 20% tolerance, means plus minus 10%, plus minus 20%. Okay, all those tolerance in the statistics also they are giving a plus minus error. Okay, so that is a tolerance band. So it is processing that temperature, whatever is collected or data is transmitted to the brain or process. Before processing they will collect, then after processing they have collect that value is more than of your threshold value or the less than of your threshold value. If it is more than of your threshold value, then immediately what happen, it is sending the signal to the motor neuron. Okay, to the motor neuron, and the neuron is directly connected to your bones and the muscles. Okay, sorry, connected to the muscles, and muscles also connected to the bones, and your bones they instruct it, kindly remove your hand, immediately it can be removed. Okay, means as an electrical engineer we can able to see the same thing in our closed loop feedback system. So the sensor is there. Okay, so sensor is there. From the sensor we are collecting the data. If the sensor means it can be transducers, it can be sensor. Sensor means always whatever physical response are there, it is converted to the electrical signal. That is done in the transducers. In the sensor, whatever physical signals are there, it can be converted to the any kind of signal. That is in the sensor. Okay, normally we are dealing with the transducers. So it is getting the it is getting the data, then the data is coming to the processing unit through the ADC converter, analog to digital converter, and that will be the DSP processor, whatever processor will be there connected to your computer. Okay, you are processing the data. There is a controller. Controller is trying to reduce that error or compensator. You can say in better manner, it can be represented compensator. So it trying to compensate that error value. Error value means there is some preset value, reference values are there. Okay, so there is some preset value, reference values are there. Now it is calculating how much error is there, what is your actual signal and what is your reference signal. Reference signal means already preset value, it is given in our brain, threshold value. Okay, so now what is our actual value? That error is more means that actual value is lesser than your threshold value. Means you are getting the positive error. If you are getting the negative error, means what happened? That actual value is more than of your reference value. Okay, now the compensator is trying to compensate positive to trying to be nearer to the minimum value, means trying to converge it. Okay, like that convergent criteria. Okay, so you know, like that basic optimizations problem. Okay, so trying to minimize it. So after that, what happened? You are getting the signal. Okay, so as it is a power electronics converter, so what happened? You are using the, there is a gate. Okay, so you know, like that motor neurons are sending to the signal to the muscle, then muscle is connected to the bones. Okay, means you know, like that in electrical engineering point of view, it is called like that. You know, like that driver and the actuator. Okay, so it is the signal is coming to the driver, driver is sending signal to the actuator, actuator perform the problem. So immediately we are removing the hand. So whatever process is done, as an in the biological terminology, it is called that reflex arc. Okay, and as an electrical engineering point of view, it is known as different manner. It is known as response time. It is known as control system language. It is known as rise time. As first year we are talking about the, you know, like the time constant of the system. So entire system will be related like that. Okay, so the control scheme is important. Then finally the implementation. So whatever the things we are able to see like that, good line regulations means any kind of disturbances are coming in your input side. So eh, output should not be hampered more. We maximum tolerate less than 5% input regulation. Because of that, input is changes more means output will be highly diverging. Okay, next one is the load regulations. Okay, any kind of disturbance is coming to the output side, so output should be stabilized value. Next is the transient response. We're talking about the transient response. So how fast, how quickly the system can be stabilized and it is working. Okay, finally we are talking about the stability. So the result should be converging, not should be the diverging. Okay, error is coming after sometimes error is coming less nearer to the zero value, or like the response time second order system, the it is coming to the steady state value, nearer to the steady state value, then good, that error should be coming to that zero. If the error is after some time it is increasing, so it is diverging nature, so it goes to the, so there is a mathematical modeling. So we are using the state phase average modeling. So that converter is there, it is on time when the switch is on, it having some setup equation, differential equation. When converter is off, it also having some another set of equations. Now we are able to find out the state variables. State variables, minimal set of variable that can define the state of the systems. Okay, so that state variables are there. So based on that, on time equations and off time equation, we are averaging them. Okay, after averaging, what happened? So like that, we are doing the whatever variables are there, that variables having two factor. One is called the DC value. This is your DC value and it is your AC value. Okay, so two factors are there, the individual value variable. So we are replacing, okay, that variable is replacing with that one DC value, and other is the AC value, the ripple value. Then we will get a big identity, like that identity. So then what happened? The steady state value and the that your AC component. So after getting the identity, we are separating them. After separating, we are getting the steady state value. Okay, that uppercase italic forms are that uppercase italic form, all are getting the steady state value. Okay, steady state DC voltage transfer function, and that lowercase those values are there. So after that, we are doing the Laplace transformations. After doing the Laplace transformation, we are able to give the control to output signal transfer function of the converter. This is the generalized transfer functions of any of the signal. Now, how it is working? Okay, suppose we are having that this is your output voltage and it is your reference value. Okay, so all the time we are getting the reference. Okay, now the sensor is there or transducer that is getting the value, and comparing here there is a comparator. It is comparing the reference value and the actual value. Okay, you will get the error signal over there. Now controller is there that is trying to reduce that error value. We are getting the control signal. Okay, now point is that suppose you are running a machines, okay, or you are having a DC voltage, you are having a voltage over there, and that voltage due to suddenly increasing of the load, this is output voltage. So output current is more, increasing load means output current is more, but power is constant. So power is constant, current is more. So how do you make it power constant? So voltage value should be less. So voltage is dipping over there. Then what happened? So voltage is dipping means error is more with the normal conditions. Then controller is there, so controller is trying to reduce that error. Now we are comparing with that PWM signal. There is a repeating sequence. Okay, so we are comparing them. Then what happened? You are able to see that pulse width will be more over there, and that pulse width feed to the switching converter, and switching converter turn on period also be more to maintain the voltage stability. Okay, this is a closed loop block diagram of a switching converter. Now we are talking about interfacing converter. So it can be any different kind of converter. So basically we are using boost kind of converter. So in boost converter, what happened? So we are using some feed forward control. So MPPT we are using over there. So any changes, this is maximum power point tracking problem. So any changes is there input side. So maximum power point always been tracked over there. Here you can able to see that MPP points. Okay, so based on that varying of your power and voltage, so the MPP point trying to be maintained over there. Okay, so it can be changed. Okay, so now we are giving more trust on that intelligent kind of controller. So why we are using fuzzy? So basically, like that, it's there in intermittency is the basic concept of the renewables. So that's why fuzzy kind of thing you can able to use to adaptive. Okay, so whatever controller you are designing, so that controller should be the adaptive one. Okay, that's why you can able to use the fuzzy one. Then you can also use that adaptive neuro fuzzy interfacing system. Means like that there are different weight are there. So that also weight can also be an adaptive, means you can use different kind of optimization technique to minimize, or you can able to select the actual values of that one. But finally you can able to plot the convergence criteria, so you can able to understand. There is some very example of a adaptive and fish based MPPT techniques. You are having some surface diagram, okay, and finally your idea is to utilize the steady grid voltage, okay, steady bus voltage. That should be your idea. So the disturbances are there, still you are getting some steady value, voltage value, okay. This is your idea. So now bidirectional converter we have already discussed. So that DC link voltage may be your 48 volt. Okay, so 48 volt they are taking an example, and that is by 12 volt. So battery is trying to discharge the 48 volt. So boosting is required, and again it is your 48 volt, and this is 12 volt. Battery is trying to charge it from your DC bus. So 48 volt is stepping down to 12 volt. Now we can able add both of the things, so you will get that bidirectional switch over there. There is a two bidirectional switch. You can able money both. There is a uncontrolled switch. This is uncontrolled switch, and this is control switch. This is control switch. This is uncontrolled switch. Now you are merging both of them, so you are getting two bidirectional switch. Based on that, you can able to working with that bidirectional converter and that gate pulses. So gate pulse you are giving over there. Okay, so gate pulse, if you giving this gate terminal, so it can be work. Okay, and bidirectional power flow can be possible. So both DC and AC output can be possible some of the cases. Okay, so another converter you have to connect that can convert both of the cases. Now we are taking some of the typical examples, two examples for the power management. So we are talking about the power management scheme. So now we are taking some typical examples for the power management. Okay, so here you are using the solar photovoltaic. Okay, and DC-DC converter is there, the MPPT algorithm from the we are controlling, and you are getting the through that MPPT algorithm is there to controlling the DC-DC converter, and you are getting the voltage that feed to the DC bus, and the DC load also be there. The here you are also using some of the control block. Okay, so the purpose of the control block is maintaining the DC bus voltage constant. MPPT controller, the purpose of the MPPT controller extract maximum power from the photovoltaic, solar photovoltaic, but it can also be possible that DC bias voltage may not be constant. That's why for making it constant, you are using another controller for the voltage loop control to making it fixed. So here you are having some of the results with MPPT controller. So IV characteristics and PV characteristics of that solar photovoltaic, with having the first figure is that you are having that constant solar irradiance with 1000 watt per meter square. And second characteristic is that for that constant temperature with the solar photovoltaic. So in this case here, so, irradiance is constant, but temperature is changing. So you can able to see the voltage also be changing. Okay, better result you are getting with lesser temperature, and less voltage you are getting with that more temperature. Okay, so irradiance has changed means you are getting that power is irradiance is more means you are also getting the better solar power, and as well as the current also being more means more current is flowing to the solar photovoltaic. And here you can able to see some of the constant output voltage in different conditions. Irradiance as changing, it is abrupt changing you are get, you can able to see irradiance and temperature. So without voltage controller, in a previous slide we were talking about that voltage controller is there, so you are getting steady output voltage. Here you are getting the steady output voltage, but the voltage controller is not there in the green curve, so you are not getting the steady output, so it is varying. Okay, so the bidirectional converter also be there. For modeling we are using for designing the current controller and the voltage controller. So transfer function we have to calculate, then we can place the values of the parameter value, and we will get the final transfer function, and based on the transfer function, so we can design the voltage, and we can able to design the PI controller for the voltage loop and the current loop by using the series CISO tool. Okay, in MATLAB tool, another thing is there that is called CC input series output toolbox. From this toolbox, you can easily design that different kind of controller. So in this work, first we are working with the PI controller. Okay, so battery is there. So battery is charging means battery current, you can able to see negative. So this is current. Normally we are taking current. Okay, so current is positive. If we are giving current, so we can say like that battery is charging, means battery is charging means negative. So the state of charge, SOC means state of charge. So it is gradually increasing, then it is steady state value, then it decreasing. So here you can see at zero means here it is zero means up to that point battery is charging, then battery is discharging. So you can able to see that current value also the positive. Okay, as well as the battery voltage is there. Okay, so in this battery voltage, so current is increasing, power constant we are taking. Okay, current is increasing means voltage is also decreasing. Okay. Now four conditions we are able to see. First mode of operation, we are observing that solar photovoltaic equal to power of generated from the solar photovoltaic equal to power generated from your power required for the load. Second condition, PPV is greater than P load. Third condition is PPV is less than P load, and finally PPV is varying with the storage. So first case that PPV equal to P load means there is no additional power, and second case that generation is more than of your load demand, so additional power will go to the storage. Third case you can able to see that generation PPV is less than of your load demand, so more power will come and storage will be discharged, and PPV is varying. Okay, here both anything can be happen. Okay, so first mode, both PPV equal to P load. So you know like that the solar power generation is increasing. Okay, so like that it is increasing. So power from the load power also will following it. So it is also increasing like that. Okay, so as the power is increasing, so definitely voltage will be decreasing. Power equal to voltage into current. Okay, so power is increasing means definitely the current is increasing. So voltage is decreasing, maintain it constant. Second condition, PPV is greater than P load. So PPV greater than P load means additional power. So that is battery power. Battery power equal to how much? P load minus PPV. So additional power is that coming to the battery. So here you can able to see this is your generations. Okay. Now the changes is there from there. So because the load power is increasing, load is increasing, current is increasing. So battery power, you know, like that initially battery power is minus 7,000. Okay, watt minus 7. Now it is decreasing, it comes to the 4,000, is decreasing, is zero. When I gradually you are increasing load means battery charging also gradually decreasing. So SOC level also be initially you can able to see increasing like that. Okay, so then it is steady. So battery current is also minus value to plus value. So what happened, battery is charging. So battery voltage also being plus value to gradually coming to the reduced value. Okay. This is third condition, PPV is less than of your P load. Okay, so all the simulation is done in the MATLAB. Okay, so PPV is greater than less than of your P load. So battery power equal to P load minus PPV. So additional power is coming from the battery. It is your solar photovoltaic generation almost constant in 11, 12,000 watt. Okay, means 12 kilowatt. Now power you are increasing. So this is 12 kilowatt. So increasing to 12 to 13, then 13 to 14. So it is more than this one. So initially both of the cases 12. This is 12 kilowatt. This is 12 kilowatt. So they are cancelling each other. So no additional power will come from the battery. So that is battery power is zero. When power from the battery is zero, then is increasing. Load is increasing, but generation is constant. So additional power will come from where? So additional power come from your battery, and finally more load is increased, so more power. So you know like SOC power, battery is discharging, so positive current. Okay, battery is discharging, so this is your positive current. Okay, you know like that time constant also very high. Okay, this is taking some time to reach the steady state value. Okay, here. So SOC level also decreasing. This is finally, all are changing. Load power also been changing, generation also been changing. So it is load power changing, generation. So battery power, initially battery is charging. So minus power minus 2000 is there, then gradually changes to the positive 4000. Okay, so initially SOC is increasing for the charging purpose, then it is decreasing for the discharging purpose. Okay, and that voltage also been maintained fixed. Now this is some experimental setup pictures for a bidirectional converter, converter is using over there. Now we are talking about example for the hybrid microgrid where we are maintaining the different sources. So battery is there, okay, battery is there as a source, then solar farm is there, okay, and the wind farm is there, and this is your DC grid. So we are our target is that maintaining fix that DC grid voltage with having some load. Here you can see some AC load is connected over there and DC load is connected to the DC bus, and this is your utility grid and the circuit breaker is there. Okay, so our main target is to maintain that DC grid voltage for changing of the load or any kind of changes. Okay, so this is your system configurations. This is solar photovoltaic system. This is solar photovoltaic system. The bidirectional that P and O algorithms are there. Okay, with the DC to the boost converter, then feed to the DC is your DC grid. Okay, so you can able to see the DC grid and the wind system, wind power also been connected over there. There is a converter. Okay, that connected to the DC grid. The load is also connected. So this is your DC bus. Okay, DC bus, and there is a bidirectional converter. This is bidirectional converter half bridge. Okay, so only one leg is there, that is half bridge bidirectional converter, and this is a bidirectional AC-DC converter to transferring the power from DC grid to AC grid. Okay, this is interlinking. This is interlinking converter or bidirectional DC-AC converter. This is bidirectional DC-DC converter. Okay, now we are fixing up that voltage level of that DC bus with different condition. Different case studies are there. Mathematical modeling is using for that value. Okay, to design the controller. Now 6 cases are there. Okay, with the power management scheme. Okay, so with for a hybrid microgrid. So we are doing the performance checking with a variable load power demand. Okay, variable load power demand with constant generation. So generation is constant. So like the P load, that P load is increasing. So gradually increasing. PPV is more or less same with the changing of that wind speed also same. Now what happened? You are changing that solar irradiance. Okay, so where is your solar irradiance? So you are changing that power managements. Okay, so load demand. Oh, sorry, solar irradiance is same. Your PV is same and solar irradiance has changed same. So only the P load you are increasing. Okay, that P load is increasing. So P load is increasing. So generation is constant. So from where the additional power will come? So definitely it will come from the battery, P battery. This is your P load, and additional power will come from the P battery. And like that, this is your DC bus voltage. So where the changes happened, here the changes happened. So that point you can able to see some of the spikes. Okay, the spikes are there on the changes of that value, here only, here only. So spikes are there. Okay, and end of the day it is maintaining fixed. So first condition is a variable load power. Second condition is that under the variable solar irradiance. So solar irradiance and the constant load power. So P load is now constant. Previous diagram, the P load is stepwise changing, staircase kind of thing. Now P load is constant. What portion, what thing you are changing? Solar irradiance you are changing. Okay, solar irradiance, here you can able to see the solar irradiance changing. So it is abrupt kind of changes. So with the changes of the solar irradiance, so PPV has changed, the generation PPV has changed. So some of the figure we can able to see with the changes of the solar irradiance. So PPV have changed. Okay, but wind speed is constant, but additional power will come from the battery, and DC link voltage also be maintaining fixed. Okay. Second, the third conditions what happen under variable solar temperature. So temperature also being changed, solar temperature. Okay, solar temperature, this is solar temperature, it has changed. So the generation of the solar also being changed. So P load is same. So only the solar generation has changed. So additional power will come from the battery. So we can able to see. Next, fourth case is that so variable wind speed. Sorry, under the variable wind speed. So now wind turbine is affected. So wind speed, here you can able to see the wind speed has changed. Okay, so because of the changing of the wind speed, so what happened? The constant thing solar P load is fixed. So from where additional power will come? So battery, here you can able to see the additional due to wind variation, wind speed decreases, the battery satisfy the load demand. Okay. Condition 5, you can able to see variable wind speed, solar radiations, okay, temperature, constant load power. So if the load power is constant and all are changes, irradiance, temperature, and wind speed. So battery is there. B battery is constantly maintaining the DC bus voltage. Here you can able to see it is some transient is there, but end of the day the average value is same. Okay. Final conditions all are changing. Variable wind speed, solar irradiance, temperature, as well as variable load power. Various load power also been changed. Case 6. So all are changing. So it is fixed almost. Okay. So the six key case studies we can able to see. In the power management scheme, what happened? The hybrid systems such as battery bank and the supercapacitor will be used for the power generations. Okay, so battery having and higher energy density, wind having supercapacitor high power density. So both are work supercapacitor. So HESS hybrid energy storage system consists of battery and supercapacitor energy storage for energy stability from the solar PV power generation system. Several cases we have already discussed. So what are the important thing? Keeping the power equilibrium for all the system, improve DC bus voltage regulations with comparison of the uh, conventional control strategy in terms of voltage overshoot, effective power sharing among HESS, that state of charge supercapacitor within the specific time limit, and that increase of the performance of the battery by preventing the action high frequency ripple current and high rate of depth of discharge. Okay, so these all are the very basic things. So this is the power management schemes. Okay, algorithms are there. From there we can able to see over there. Okay, so when the excess power mode, deficit power mode, both of the mode. So here the conditions are there. Whatever we are discussing with some example, the same thing is given in the mode of flowchart. Okay, so the exams will already given. I hope you are able to understand. Now the flowchart manner it is showing, it is over there. Okay, so we are using intelligent power management scheme. Okay, so that's why fuzzy, there are rule based fuzzy, so surface diagram everything is there. So which type of converter you are using? Adaptive fuzzy controller with the multi-state fractional order PID controller you are using. Okay, so supercapacitor storage, battery storage, wind and photovoltaic. So this is your DC bus and this is AC bus. Okay, both we are using. So interlinking converters are there. In between DC bus and AC bus, the AC load is connected. This is standalone conditions. The specifications are given over there and that VWM. So based on that power management scheme, the control signals, or like the gate pulses are generated. That gate pulse is given to the bidirectional converter. So two set of bidirectional converter is there. One is connected to the supercapacitor module, another is connected to the battery storage module. So bidirectional converter will bidirectional give that one, so signal, so battery DC bus voltage is maintaining constant. So with some variable loads, how it is maintaining, so here we can able to see some results with intelligent control outcome. So previous cases, whatever proposed classical methods are using, now intelligent control are using. Same study. So initial the transient is there. You can able to see very fast, that reaching is very fast, but initial one it is, yeah, super capacitor is connected over there. Okay, so that's why the state of charge battery, state of charge of super capacitor. So okay, both are there. Okay, so this is for variable load with DC microgrid. This is variable generations. Okay, DC microgrid. So variable load of the hybrid microgrid. Okay, so now load also been changing. Okay, both the controller we are comparing previous cases controller and now intelligent controller. Intelligent controller results is better. Finally, we are doing the robustness study with the parametric uncertainty. Parametric uncertainty means we are means like that with the aging effect. Okay, so if you able to see the real time controller, so due to the aging effects and with the variation of the time, so the controller having some changes is there. So robustness study is also important. So this is a setup, different setup we have designed in our laboratory for the real time applications. That's it. That laboratory is funded by the Department of Science and Technology, seed divisions. Okay, So now we can able to see some of the coordination kind of control. So as the time is less, so we are trying to manage all those things. So synchronization is the very much important. If you have that different multiple sources, so how all the sources will be involved if the frequency is mismatch, so how that will be working together. So normally it's done in the coordination control. Okay, so next we can able to see different type of control with that decentralized control, centralized control, and that like that EA control means distributed controls. Okay, so in decentralized control, individual controller having converter having converter having some controller. Okay, so that is a decentralized control. So there is no correlations between your local controller. LC means local controller. Okay, two local DG means distributed generations. Okay, but in case of centralized control, what happened? All the local controllers are connected by a microgrid central controller. Okay, so that is quite complicated. Okay, so with single controller controlling all of them is quite complicated. So that's why basic one is that we have to use a distributed controller. So here there is a communication in between the two local controller among of all the local controllers. So that is a coordination control. So it will be quite better. So thank you. So if you are having any doubt, please let me know. So we can also discuss it. So any query from that your end?
No, sir.
Hello, sir.
Please tell.
Sir, actually, I have a doubt. Like, you kept irradiance constant and increase the temperature, right? That is
Madam, please tell me.
that practically, in what case we can have that condition, sir? Because when irradiance is maintained, what is the possibility of increase in the temperature in the system, sir?
Actually, in this study, what we are doing, we are changing the irradiance is quite abrupt manner. Practically, it is not like that. If you see
Okay.
the practical data that we are also having the study on that as so limitations of the time we cannot show all those results. So it is look like a gradually it is increasing, then reach to the top again comes down to that one. Okay, so this has happened in the practically, and temperature cases also doing the same. Okay, and if we implement our algorithm, that also working fine with those things. But here we are taking the example with having abrupt changes. Means suddenly 1000, then it is changed to 1200, then again reduced to 900. But practically it is not happen. Practically gradually. But here we are giving abrupt results and abrupt differences. Why? So sudden changes, how the controller will be affecting, how the controller is responding. That's why we are considering the abrupt changes.
Sir, and one more thing, see, when I could see this plot of SOC,
Hmm.
it was raising from 80 SOC from 80 to somewhere higher level. Normally, like, won't it be limiting the charging level to till 8 only? How can allow the battery system to like charge from or increase the state of charge from 80 to so higher level? So can we allow the battery to charge till 100%?
Actually, actually, there are different. This is just for simulation results. Okay, this is not actual experimental results. Suppose if you want to see the actual experimentations, in that case, what we need to see first, we need to see the data sheet of the battery. Okay, so if we are able to get the data sheet of the battery, okay, so 1 minute.
Undefined function. Same TS.
So 1 minute. So what we need to see, what is depth of discharge, what is the maximum charging capacity. Okay, but we are running the battery in such a way. Okay, so it should not be reach up to 100%. Because of that, when we are using that BMS, battery management system, there is quite important parameters also be there. One is SOC, state of charge. One is another thing is the state of health. Okay, temperature of the battery, all those things are there. Okay, so here whatever you are pointing out, 80 to 80 point something, so that is only for the simulation study, means the battery is charging, SOC is increasing, that we need to see. And another thing is that battery also mean that slope is also important. Money, so how much angle is there? We cannot abruptly charge. Getting my point? So slowly it should be increased, then one level to another level, then another level to another level. Like that, it will be charged. Okay.
Okay, sir.
Okay. So is there any other doubt? Any other query?
Difference. We spoke first math. Second వచ్చి కరెంట్ మాత్రమే. థర్డ్ వచ్చేసి రెండు కలిపి
Sir, I
చూపిస్తుంది ఇక్కడ. yellow కలర్ కింద చూపిస్తుంది కానీ బ్లూ కలర్ చూపిస్తుంది కరెంట్ వోల్టేజ్.
Okay, so I hope there is no query. Okay, so here we can stop the session.
hello, sir.
Please tell.
Can you hear me? Yes, sir. I
Yes.
missed the last few slides of yours. So I would like to know the references for the few things like how you fix the sizes of the microgrid, and then also the protocols and standard slide you have put now. I would like to know the references for that.
Okay,
Will you be sharing?
references.
Will you be sharing the
References.
slides?
Definitely. I'll share the slides. Okay, you will get it from my slides. I'll share everything. And if you want to know more about the power management, so directly you can follow our publications. You can, if you see our profile, so a lot of things are available in my profile. So power management work, if you want to carry on, you can see a lot of papers in this domain to us. Okay, so you can follow them, no problem.
Okay, thank you, sir.
Okay, thank you. So now we can stop this session. So next session will be taken by Professor Prabhat Kumar Ray. Okay, so it will be started approximately 3:30 onwards. Okay, thank you.
Thank you, sir.
Thank you, sir. Thank you. ఏ సిగ్నల్స్ సెలెక్ట్ చేసుకున్నామని లిస్ట్ వస్తుంది. ఈబీఆర్ఎల్, ఈబీఆర్ఎల్, ఐబీఆర్ఎల్, ఈబీఆర్ఎల్, ఈ సోర్స్, బీసీ వోల్టేజ్ సోర్స్.
Sir, next session will be in 3:30.
ఇప్పుడు మనం
Hello. Hello.
సోర్స్ వోల్టేజ్ ఐబీఆర్ఎల్, ఐబీఆర్ఎల్ 4 పెట్టుకొని అంటే 4 సిగ్నల్స్ ఇది చూపిస్తుంది. మళ్ళీ సింక్ లో ఒక స్కోప్ పెట్టుకొని అన్ని ఒకసారి 4 ఒకటే స్కేల్ మీద వస్తుంది. 4 అంటే 5 ఫంక్షన్ 4 అంటే ఇందులో 2 ఉంటే ఇందులో 2 ఉంటాయి. ఎందుకంటే కరెంట్ రెండిట్లోనూ ఒకటే, ఇందులో రెసిస్టెన్స్ లోను ఇండక్టర్ లోను కరెంట్ ఒకటే, వోల్టేజ్ ఒకటే తేడా ఉంటుంది. ఒకటేమో వోల్టేజ్ 0 ఉంటుంది, ఇంకోటేమో వోల్టేజ్ ఫుల్ వోల్టేజ్ ఉంటుంది. V/R R1 కాబట్టి కరెంట్ వోల్టేజ్ ఒకటే ఉంటుంది. మళ్ళీ R1 ఉంది కదా, চেঞ্জ আসবে।
তোর ভিডিও অন ছিল, বাট আমি সব ভিডিও দেখতে পাচ্ছিলাম না, কারণ পুরোটা তো দেখা যায় না। না কখনো অন করেছিলি তো চাপ নেই তো, মানে ভিডিও অন থাকলেই বা হোয়াট ইজ দ্য প্রবলেম। অ্যাকচুয়ালি আমার কাছে সব ভিডিও তো দেখাচ্ছে না, না আমাকে একটা পার্সিয়ালি শো করছে, মানে তোর অন্য কেউ চলে এলে তার স্ক্রিন চলে আসছে, এরকম হচ্ছিল।
ట్రాన్సియెంట్ రెస్పాన్స్ అక్యురేట్ గా రావాలి అంటే స్టెప్ టైం చేయాలి, స్టెప్ టైం
ঠিক আছে,
పెంచుకోవాలి, స్టెప్ టైం ఇంక్రీజ్ చేయాలి, డిక్రీజ్ చేయాలి, సరిగ్గా చేయకు, డిక్రీజ్ చేస్తే ఇంకా ఎక్కువ వస్తాయి కదా। స్టెప్ టైం డిక్రీజ్ అంటే ఏమనుకుంటున్నావు? స్టెప్ టైం డిక్రీజ్ చేస్తే నంబర్ ఆఫ్ స్టెప్స్ ఇంక్రీజ్ చేస్తాయి, స్టెప్ టైం ఇంక్రీజ్ చేస్తే నంబర్ ఆఫ్ స్టెప్స్ అనేది డిక్రీజ్ అవుతుంది। అవును, దీనివల్ల ఇంకా ఎక్కువ స్టెప్ టైం డిక్రీజ్ చేస్తున్నాం, చేసాము చూద్దాం, అంటే ఈ గ్యాప్ తగ్గిస్తున్నాను అంతే కదా మేము ఉద్దేశం। ఆ గ్యాప్ తగ్గించడం వల్ల ఇంకా నెంబర్ ఆఫ్ పీక్స్ పెరిగిపోతాయేమో అని చూద్దాం। ఫాస్ట్ గా స్టడీ స్టేట్ వచ్చేసింది। ఇప్పుడు చూస్తే స్టెప్ టైం తగ్గిస్తే మనకి యాక్యురేట్ వస్తుంది, ఎక్స్పెరిమెంటల్ వేగం యాక్యురేట్ వస్తుంది, ఓకేనా? అది దీని సంగతి। ఇక్కడ నుంచి నెక్స్ట్ మనం ఆర్సీ చేసుకోవచ్చు, తర్వాత దీన్ని వోల్టేజ్
তুই বললি তো ওয়েট করতে, তাই ওয়েট করছি। চল বেরোচ্ছি,
বেরোচ্ছি, చూద్దాం। ఓకే, నెక్స్ట్ లెవెల్ ఆఫ్ డిస్కషన్ ఓకేనా? మీకు అందరితో మామూలు కూడా తిన్నాను, కూడా తిన్నాను అమ్మాయినా అలాగే వస్తావా అని అడగకూడదు, రండి తినడానికి అని చెప్పాలి। ఇంకో బలం ఉన్నాయా కదా, రమ్మని లెటర్ రావట్లేదు బాగా తల్లి, అవును ఏం లెటర్